Algebra 2, Trigonometry Region, January 2011, question 1. Which graph does not represent a function? Well, a function only has one y for every x. So let's see, that means there should be, when you make a vertical line test, that line should not hit the graph twice. So we're going to take a vertical line. We're going to take a ruler, and we'll look at answer 1. Answer 1, you move the vertical line, the ruler, across the graph, going up and down will only hit the graph once. So that is a function. Answer 2 will also hit the graph only once, going across. Going like this, the vertical line will be a horizontal line. It will hit it a few times, but we want a vertical line. Whatever hits the graph when the line going up and down hits the graph that we made, the line that's made from the function, only once, going all the way across, that's a function. Answer 2 is a function. Answer 3 is a function. Answer 4 is not a function because you see, with this vertical line, it hits the graph in a few spots. It hits it over here, and over here, or over here, and over here. So that is not a function. So the question is, which graph does not represent a function? The answer is answer 4, because it does not pass the vertical line test. Because when you make a vertical line, you see that it will hit the graph, that the S that is made more than once. So the answer is answer 4. Question 2. The roots of the equation x squared minus 10x plus 25 is equal to 0 are either answer 1 imaginary or 2 real and irrational. Question 2. The roots of the equation x squared minus 10x plus 25 equals 0 are either imaginary. These are the answers. They ask you, are they imaginary? Are they real or rational? Are they rational, real, or equal? Are they real, rational, or unequal? This you have learned in Algebra 1. So let's try to figure out what are the roots of these equations. To find out the roots of these equations, you use the discriminant. And the discriminant is what's under the radical sign in the quadratic equation. The quadratic formula is that x is equal to negative b plus or minus the square root of b squared over 4ac, and that whole thing is divided by 2a. But the discriminant is, well, we're discriminating from the regular numbers. The radical number is what's under the radical sign. So the discriminant is b squared minus 4ac. So what is this a, b, and c? Well, besides being something that you've learned in first grade, it is also represents numbers, because it's a regular quadratic formula is ax squared plus bx plus c equals 0. A, b, and c are the numbers before the x's. So ax squared, a is a number times x squared, b is a number times x, and c is a number times x to the 0 power, which is just times 1. So it's just 25. So let's see, what is a? What is x squared multiplied by? Nothing. So if it's multiplied by nothing, in order for it, you can't multiply it by 0, so it's always multiplied by 1. So a is 1. So x squared, plain x squared is x squared times 1. So a is 1. B over here is negative 10, because it's x times b, and it's negative 10x. So b is negative 10, and c is plus 25, or plus c, so c is 25. So we need a, b, and c over here. So the discriminant, again, is what's under the radical sign. So b squared is negative 10 squared minus 4, a we said is 1, and c is 25. So remember, it's negative 10 squared minus 4 times a times c, or minus 4 times 1 times 25. So negative 10 to the second power is an even amount of negatives, becomes multiplied together, becomes a positive. So negative 10 times negative 10 is a positive 100. Minus 4 times 1 times 25 is 100. So 100 minus 100 is equal to 0. Now, the Is it imaginary? 0 is not imaginary. So answer 1 is out. Is it a real number? Well, look at all numbers that are not imaginary are real. So it is a real number. Are they rational? Well, rational numbers are numbers that come to an end. Let's say 1.25. Irrational numbers is if you put a number in the computer, in the calculator, and you hit the radical sign, and it just goes on and on. That's irrational. So it's not irrational. It's real, it's rational, and they're also equal because negative 10 squared is equal to negative 4 times 1 times 25. I mean, negative 10 squared is equal to 4 times 1 times 25, because 100 is equal to 100. So the answer is answer 3. Now, answer 4. Real, rational, and unequal. Well, they are equal. Now, how can we make the answer 1 correct, imaginary? Well, we can make them imaginary if what's under the square root, negative b squared minus 4ac, if that will come out to a negative. Because let's say it will come out to negative 3. So then it would be equal to the square root of negative 1 times the square root of 3. And the square root of negative 1 is I. So I is for imaginary. So it's, instead of square root of negative 1 times radical 3, it's I times radical 3. And so therefore, the answer to this, they are both equal. They are real numbers because they're not imaginary, and they're also rational numbers because they come to an end.
Wait.
It's off. Question 2. The roots of the equation x squared minus 10x plus 25 is equal to 0 are either one of these 4 answers. So, is it imaginary? Is it real or rational? Rational or equal or unequal? We'll find that in a second. Let's write it out. You have x squared minus 10x plus 25 is equal to 0. I'm going to do it the way we did it in the 9th grade. Factor it out. X squared minus 10x plus 25 is equal to x minus 5 times x minus 5. Because you see x times x is x squared. Outer is x times negative 5 is negative 5x. Inner is negative 5 times x is another negative 5x, which gives you a total of negative 10x. And negative 5 times negative 5 is equal to 25. So therefore, therefore x squared minus 5 times x squared minus 5 is the same thing as x squared minus 10x plus 25. And that's equal to 0. So either one of these two have to equal to 0. Either x minus 5 is equal to 0, or x minus 5 is equal to 0. Well, if one of them is equal to 0, the other one is also. So if x minus 5 is equal to 0, then x is equal to 5. So both of these roots are the same. This is a quadratic equation. If you see, I wrote it over here. And this spot over here, where x is equal to 5, that's where the quadratic equation goes up. And the question is it imaginary? It is not imaginary, because if you would use the discriminant rule, which is b squared minus 4ac is and b squared has to be equal to 4ac. That's also finding the roots. So over here, a is equal to 1, b is equal to negative 10, and c is equal to 25. Because the a, b, and c over here are the numbers that are connected to the x's. So x squared has a 1, because anything times 1 is itself. The x over here has a negative 10, and c has a 25. So we'll put it in. B squared is negative 10 squared, and it's minus 4 times a, which is 1, times c, which is 25. And if these two are equal to each other, which we know they are because we saw that the roots are equal, so then it will not be imaginary. So because we have one minus the other, you'll get 0, and the square root of 0 is 0. and imaginary will give you a negative under the square root sign. So the answer 1, so this is negative 10 squared is equal to 100, minus 4 times 1 times 25 is also minus 100. So what's under the square root sign is equal to 0. So therefore answer 1 is not correct. We're going to cross it out. Answer 2. Is it real? Yes. 0 is a real number. If you remember from elementary school. Is it irrational? No, it's not irrational, because irrational numbers are numbers that don't come to an end. So answer 2 is also out. Now, we said it's real, it's rational, because it comes to an end, and also it is equal. So answer 3 is the correct answer. The answer to question 2 is answer 3. How about, are they real, rational? They are. Are they unequal? Is 100 equal to 100? It is equal to. Are these roots the same? X, we know that the only time where x hits where the equation hits the x-axis, where y is equal to 0, is 5. So there's only one root. So the two roots are equal because there are only one root. That's why they're both the same. So they're not unequal, so answer 4 is wrong. So the only correct answer to question 2 is answer 3. Question 3. Which value of x are solutions for this equation x to the third power plus x squared minus 2x equals 0? So first we'll have to factor it out. Question 3. Which value of x are solutions to the equation x to the third power plus x to the second power minus 2x equals 0? Well, you have to factor it out to find out what are the values of this equation, what are the roots. So the way to figure it out is you have to factor it out. So what is x cubed, x squared, and negative 2x have in common? They all have an x. That means you could divide this equation by x. When you divide this equation by x, so x cubed divided by x is x squared, plus x squared divided by x is just x, minus 2x divided by x is just negative 2. So therefore, since you divided it by x and you got x squared plus x minus 2, so therefore when you multiply it by x, it will bring you back to the original equation. So therefore, put an x in the outside, x times this equation is the original equation. So x times x squared plus x minus 2, and you have to factor out more to find the roots. So so first thing is, since you just have an x squared, you factor into FOIL form, first, outer, inner, last form. You do x plus and minus, and when you add it together will give you a positive x, and when you multiply the two last ones together will give you a negative 2. Well, x plus 2 times x minus 1, because if you do you do FOIL, first, outer, inner, last, x times x is x squared, x times negative 1 is negative x, inner is 2 times x is 2x, 2x and the negative x is just a plain positive x, because you have 2x and you have a negative x, so you have to subtract 1x from the 2x's, so it leaves you with an x, and 2 times negative 1 is negative 2. And of course we know it's equal to 0, that's what's shown. So, one of these things has to equal to 0. If, for this equation to equal to 0, they can't all equal 0. Either x is equal to 0, or x plus 2 is equal to 0, or x minus 1 is equal to 0. Because one of them multiplied will make this equation equal to 0. So either x is equal to 0, or x plus 2 is equal to 0. Then if x plus 2 is equal to 0, so what is x equal to? Subtract 2 from both sides, x will equal to negative 2. And if x minus 1 is equal to 0, so then x is equal to 1. So if x plus 2 is equal to 0, that means negative 2 plus 2 is equal to 0. Or if x is 1, so 1 minus 1 is 0. So either x is 0, negative 2, or 1, which is answer 2. Question 4. The diagram below of a unit circle, over here it's not the diagram below, because if I would write it below, I have to do a whole new painting. So the diagram below, over here it's on the board, is a unit circle. A unit circle means that from the origin, the middle of the xy graph, to the end of the circle, the furthest point from the origin to the end of the circle is equal to 1. Now, its terminal side, in the diagram below of this unit circle, the ordered pair radical negative 2 over 2 as the x coordinate and radical negative 2 over 2 as the y coordinate represents a point where the terminal side of theta intersects the unit circle. So whenever we speak of a Greek word, we're usually speaking about angles, because in order to go in circles, remember, the quadrants go counterclockwise. So in order to know how to think Greek and think the angle, you have to think counterclockwise. We all know that counterclockwise is quadrate, because clockwise is the way you're supposed to go. But in mathematics, we go counterclockwise, we go quadrate. So anyways, Question 4. In the diagram below of a unit circle, the ordered pair negative radical 2 over 2 and negative radical 2 over 2, that's the x and y coordinates, x is negative radical 2 over 2 and y is negative radical 2 over 2. It represents the point where the terminal side of theta intersects the unit circle. What is the measurement of theta? So in order to do that, we have to take away the negative sign. What's the best way to take away the negative sign? Well, over here it's very easy. You take one of these long things, a straight ruler, and you make a line that goes direct from the line that you have in the diagram. And if you make a straight line from quadrant 3 into quadrant 1, because this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So if you make a line, we'll go straight into quadrant 1, and you'll take this point over here, instead of being, it's the same distance, instead of being a distance of negative radical 2 over 2, it becomes a distance of a positive, because over here it's negative, the xy, and over here the xy is positive. So therefore the x will be a positive radical 2 over 2, and the y will also be a positive radical 2 over 2, the distance. Why is that so? Because whenever you deal with a unit circle, the x coordinate is 1, that's a unit circle, and the y coordinate going up is also 1. So if x is 1 and y is 1, and you know we're making a right angle, so you have the Pythagorean theorem, which is a squared plus b squared equals c squared. So 1 squared plus 1 squared is equal to c squared, which is equal to 2. And we want the square root of 2, which is radical 2. So if x is 1 and y is 1, so its hypotenuse will be radical 2. So how did we get radical 2 over 2? Well, the sine and cosine, the x coordinate is the cosine, and the y coordinate is always the sine. So let's take the sine. What is the sine? The sine of this coordinate over here, we know is opposite. Here's the sine. We know opposite is 1. And over hypotenuse. Sine is opposite over hypotenuse. From SOHCAHTOA, sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So now we're doing the sine. We're not doing tangent over here. Sine is opposite over hypotenuse. Opposite sine theta over here, which is not exactly sine theta, but it's its mirror image. So its opposite is 1 over radical 2. So how do you change that from, how did it become all of a sudden negative radical 2 over 2? Well, they never allow you to put a radical in the denominator. They always want you to put it back in the numerator. So in order to put it back in the numerator, you have to take the 1 over radical 2 and multiply that by radical 2 over radical 2. Because anything over itself is equal to 1. So all you're doing is you're multiplying it by 1. Because radical 2 divided by radical 2 is 1. So it's 1 over radical 2 times 1, or 1 over radical 2 times radical 2 over radical 2. Well, 1 times radical 2 is equal to radical 2. And radical 2 times radical 2 is radical 2 squared. But radical 2 squared, you just take away the radical and you make it into 2. So that's how they got radical 2 over 2. And it became negative because x is negative, because you're going to the left of the graph, and then y is negative because you're going down. Over here, so let's find the sign, the inverse sign of radical 2 over 2. You take out your calculator, the T983, T984, and all the calculators could do the same thing. You hit the sign, or the second button, you hit the button to make it into inverse of sign, either second or switch sign, and you hit sign, which will make it inverse sign, and then all you have to do is you do 1 divided by second sign again to get the radical, 2, close parentheses, and you'll get 45 degrees. Now, it's not 45 degrees, it's 45 degrees, and we want to find what that is in the third quadrant. Well, in the third quadrant, you see it's made up of 90 degrees. So you already did 180 degrees. You have to go another 45 degrees to make this into a straight line. So if you do 180 plus 45 will give you 225 degrees. So what is the measurement of angle theta? The answer is 225 degrees, which is answer 3. Question 5. Question 5. What is the 15th term of a sequence that is 5 jumps to negative 10, to 20, to negative 40, to 80? So, to figure out the 15th term, we first have to figure out what's the jumper. Well, the best way to do it is, how do you get from 5 to negative 10? To negative 10 divided by 5, you see it's 2. If you do 20 divided by negative 10, you see it's negative 2. Just like negative 10 divided by 5 is negative 2, so to 20 divided by negative 10 is 2, negative 40 divided by 20 is negative 2, and so on. So now that we know that the jumper is negative 2, what is the 15th term of the sequence? So we know that the first one is 5. So therefore it's 5 times negative 2 to the 0 power. And that's the first sequence. That's the first one. And you have to multiply this negative 2, 5 times negative 2, another 14 times. Negative 2 has to be multiplied by itself 14 times to find the 15th, to find what's the 15th in the sequence, the 15th term. So therefore, the first one is 5 times negative 2 to the 0 power. So it's 5. And the 15th term is 5 times negative 2 to the 14th power, because you already have 5 times negative 2 to the 0 power. Another way, and the way we would do it is 5 times negative 2 to the 14th power. So you have 5, and negative 2 to the 14th power, you put in your calculator, is equal to 16,384. So it's 5 times 16,384, which is equal to 81,920, which is answer 3. Another way to do it is you take the 5, like this, you erase this whole thing, and you do 5 to the negative 2 to the 14th power, because it's 5 times negative 2 to the 15th term. However, you already have the first term, so you have to subtract one of the powers. That's why it's only 5 times negative 2 to the 14th power, because the first term you have. So therefore, you only have to multiply negative 2 14 times. So therefore the correct answer is answer 3, 81,920. Question 6. What is the solution set for the equation of the absolute value of 4a plus 6? When you subtract 4a, it will equal to negative 10. So first thing we have to do is we know that an absolute value, and since the a is inside the absolute value, that means we have to take what's inside the absolute value and say what will be if it's negative and what will be if it's positive in order to find all answers for a. So first what we're going to do is, we're going to do 4a plus 6. I'm going to move what's outside the absolute value to one side of the equation, and what's inside the absolute value will stay on the other side. So this way we separate it, and we can give you the absolute value of something times a minus something will equal a positive.